Okay, so this is still day one, and it's just going to be called part two. It's going to be pretty short, but it's just kind of two different concepts, so I wanted to discuss this separately. Where are you fresh? Okay, so let's look at this one right here. I am not fresh, however, because I have been going all day at work, and now it's a fun Tuesday night of notes. So I want you guys in your calculators. I want you to go to Math 9. Okay, so in our calculators, we're going to go to Math 9, and I want you to put this in. So Math 9, and we're going to go -3 to 1 of 2x plus 4, and then dx. So, oops, right here. So it should look like that. Okay, and then go ahead and hit enter. That will give you the exact area. So in our calculator, we can see that this exact area is 8. So now what I want us to do is to go ahead and graph this function, and only from -1 to 3. I want us to graph f of x only from -1 to 3. So let's see it. -3, that would be -6 plus 4, which would be at -2. And I can see my slope is up 2 over 1. Get on there. Up 1, 2 over 1. And here at the 1, which is where we are stopping, I can see that I should be at 6. 1, 2, 3, 4, 5, 6. Beautiful. Okay, so I'm going to go ahead and connect my line, pretend that that is a straight, nice line. Okay, so then what I want us to do is just kind of, when I ask to find the area bounded by this guy on the x-axis, I'm going to connect the endpoints to the x-axis, and then just kind of draw this line through. So when it asks you to find the area bounded, it's asking you to find this area. And we've learned that if we are below, that this area is negative. And if we are above, then this area is positive. So let's go find this area. It's not a trapezoid, a triangle. So that's 1/2 base, 1, 2, 3, times height, which we already said was 6. So that gives me 9. Then below, I would have the 1/2 base times height, which would give me 1, but we know that we're below, so it's -1. So when I put those together, I get 8. So when I just am dealing with lines or semicircles or something geometric that we know how to take the area of, we don't have to do the integral. Okay, if it's just a line, then we can use just the area and geometry that we have always known. That is awesome. It's when we get into curves that aren't just semicircles or things that we know how to find areas of. This is when we will have to do the integration. Okay? And so that's kind of like showing you, hey, above the x-axis positive, below negative, don't forget. All right, so let's just kind of think about this as well. So if I started and ended at the exact same place, so I said from A to A, what is the area there? Nothing. It's like that one instantaneous line that actually doesn't exist because there's an infinite amount. So the width is still 0, okay? Even though we're adding all of these non-existent lines and getting something. Okay, we'll talk about that. But here we can see that if we start and we end at the exact same place, we have accumulated nothing. There's no area. I can also say if they have went backwards, okay, so if they have went from like 5 to 3 of that f of x, and they've went backwards because we start here and we end here, okay? I don't know if I haven't really said that, I've just kind of been implying it. But if they are backwards, then we can flip and negate, because you're kind of accumulating in reverse order, which would flip over the x-axis, and so you're getting the opposite of your answer. And this is something you guys will use all the time. This will just kind of be easy, like, oh yeah, no area, 0. Okay? The other really cool thing that I like using is this one right here. It's saying, let's say I went from 2 to 5 again. And let's say I didn't like going from 2 to 5 very much. Think about this one right here. I didn't like going from -3 to 1 very much. I liked going from -3 to -2, and then adding on that -2 until 1. That made it more convenient for me, and that is just fine. So you can split this up with any number as long as that is the same. Then you can like go to anything and then pick up there where you left off to continue and add them together. So then there's these other properties, and they're just, kind of intuitive. So if I have some constant, we can put it out in front of the integral, just like coefficients. What do they get to do? Go along for the ride. And so it doesn't matter if I have it out in front or not. It's just going along for the ride. And then this just says that if I have these same bounds, adding and subtracting, I get to split up. I do not get to split if I have multiplication. And I do not get to split for division. There's going to be special rules for those. Okay, so let's look at these examples and see if we don't need to use our calculators just yet, and we don't have to learn any of those special tricks that I was just referencing. So let's look at this first one. It wants me to find this area, and I want to use geometry. Well, how can I simplify this right here? I want to simplify it. So that is -1 to 4. And do you know what the most common mistake that kiddos write is? This right here. But when we simplify, we have to remember to get the absolute value bars, okay? Because that's going to give me a different answer if I forget them. So now I'm going to go ahead and graph this. It's the absolute value function. My vertex is at 1, and I can see my slope is 1. So it's shifted to the right 1, basically. So I know it looks like this. And I want to go from -1 until 4. So I want to find this area, and I'm going to go find this area. So I can do the 1/2 base times height. For both of those, they're both above, and I can add those together. So for my first one, I have 1/2 times my base, which is 2, times my height, which is 2. In your graph, you may need to be a little more precise so that you can actually see those values. And then I'm going to add on 1/2 times my base, which is 3, times my height, 4 minus 1, which is 3. And when I put those together, I get 6.5. Okay. On the next one, I'm going to graph this part right here. So I'm going to look at 2x plus 3 over the interval from 0 to 3. So at 0, I know that I'm at 3. And I want to go out to 3. 3 would give me 2 times 3 is 6, plus 3 is 9. 2, 3, 4, 5, 6, 7, 8, 9. And so I know that I'm looking at this area is right there. And then I still have to add 5. So for this area, I'm going to do a trapezoid. So I'm going to average out. Base 1 we said was 3, plus base 2 was 9, and multiply by the height, which was 3. Okay, so then I am also going to add that 5 on, and I get 23. Give me one quick second. Sissy, I'm recording a video. Can I call you right back? Can I call you back? Okay, okay, I'm right in the middle of a video. I'll call you back. Okay, then call me back later. Okay, love you too, bye. Sorry. Okay, so I take my 5 plus that area, and I got the 23. Okay, this one's a little bit different. This one gives me what that area would be from 1 to 2, and then they write out this weird stuff. So I want to try to organize this a little bit differently. And if you kind of remember, the plus and the minuses, I can do separately. And the coefficient here, I could take out in front of this little f of x piece, since it's not also with the 4. I've already separated it. So this part right here, they gave me. They said that is 3. So I know that I have 2 times 3. Plus, now this is just geometry again. I have the line y equals 4, and I'm looking from 1 to 2. So that's just a rectangle. Base times height, which gives me 4. And add together, and I get 10. And then the last one we're going to do here is they have it in different pieces. So that they've kind of separated it 1 to 3, and then like they're kind of picking up, but they also did 2 to 3, so it's a little bit different. But the first thing I'm going to go ahead and do is multiply that over. So I'm going to say 1 to 3 of that f of x would be 6. And then they did 2 to 3. I'm going to keep it in order and go 3 to 2 of f of x dx. Actually, you know what? I'm going to leave it. I lie. Okay. Okay, so we're going to, because they want 1 to 2. Oh, no, I'm fine what I was thinking. I'm sorry. Okay, so I'm going to go now. I'm going to flip it and go 3 to 2. And when I flip it, I'm going to write the negative. Even though I flipped it out of order, this is going to be beneficial for me because I can see that this 3 and this 3 is now the same of kind of where they've left off. So if I go together now from 1 to 2, then I can take that 6 and tag on that negative 4 and get my answer of 2. Now, another way that kiddos like to do this is they like to think on a number line. So I can see I have bounds of 1, I have a 2, and I have a 3. And so now I know that from 1 to 3, that's a total of 6. And then I know from 2 to 3, that's a total of 4. And then they asked, what is it from 1 to 2? So this we can clearly see a 6 minus 4 to be left with 2. Okay, so that is the end of day 1. Great job, and we'll start up again with day 2.